Hello world, and welcome to the Computer Scientist channel. In the previous video in this series on the client-server model and programming, we introduced the following basic concepts: clients, servers, connections, endpoints, and network I/O. We also addressed several misconceptions related to these concepts. If you haven't already, I highly recommend you watch that video before you go ahead. We also introduced the socket API as the set of standard system calls to abstract away the low-level details related to the client and server creation and interaction. While first defined in C programming language, the socket API is available in all modern programming languages as a wrapper around the original C socket API. In this video, we'll focus on Java and Python socket APIs. You will learn how to apply the socket API in Java and Python environments. You'll also be able to generalize the use of the socket API to other programming languages. Finally, you'll acquire background for our upcoming FX application case study. On the server side, the socket API allows to register a port with the OS, listen to and accept connection requests through the OS. On the client side, the socket API allows to request connection opening from the OS. On both sides, once the connection is established between the client and the server, the socket API allows sending and receiving bytes, and in the end, closing the connection. Let's see how this translates to Java. Java Socket API is defined under the java.net package. Its two main classes are server socket and socket. As its name implies, the server socket class allows issuing system calls specific to the server side, starting with registering a port with the operating system. This is as simple as instantiating the server socket class and passing to its constructor the port that we want to bind our server to. The server socket class provides the accept method, which allows listening to and accepting incoming connection requests. Once a connection request is received, the accept method returns a representation of such a connection as a socket object. On the client side, the representation of the same connection should and can only be of the same type as the representation on the server side. Hence, it should be an instance of the socket class. To obtain it, we open the connection actively by instantiating the socket class. While doing so, we specify the server endpoint in terms of its host IP address and port. We use the socket object on each side to get the corresponding input and output streams. Whatever we write on one side through the output stream gets read by the other through the input stream. Finally, the socket class supports the close method that allows closing the connection on both ends. With this in mind, let's consider a Hello World example. Here is how it goes. The client opens a connection with the server. The server sends Hello World to the client. The client prints it out on its screen. The client and the server close the connection. We start by developing the server code. Since this is supposed to run as a process, it should define the main function. First, we decide on the port we want to bind our server to. Then, we use the server socket class to perform such a binding. Notice that we need to import the server socket class from the java.net package. Also, notice that the port we selected may have already been granted to another endpoint, so this statement may throw a bind exception. To avoid memory leak, we use the try with resources construct. This way, the Java runtime environment will make sure to close this server socket and release the port on our behalf before the program ends. We create an endless loop to allow our server to continually accept a connection from the next client and interact with it. Inside the loop, we call the accept method on our server socket object. This is a blocking call, waiting for an incoming connection request. Once received, it will be returned as a socket object. Notice that we need to import the socket class from java.net package. Also, notice the use of the try with resources construct. It allows the Java runtime environment to close the connection properly on our behalf avoiding memory leaks. Now it's time for I/O. We get the output stream mapped to our socket object and wrap it with a data output stream that provides a convenient method to write our Hello World message as bytes. Notice that we need to import the data output stream class from the java.io package. Let's now move on to the client. We start by specifying the server endpoint in terms of IP address and port. In this example, we assume that the server will run on the same machine as the client, so we use localhost as a special value for the IP address. Then we instantiate the socket class while specifying the server endpoint. By doing so, we issue a system call to the OS, asking it to open a connection to the specified server. Here too, we use the try with resources construct to let the runtime environment close this connection on our behalf before the program ends. This connection opening may throw an exception if the specified server is unreachable. This could be due to several reasons. For example, there could be no server running on the designated IP address and listening on the designated port, or there could be a network connectivity issue. Remember from the previous video that at this point, the operating system picks an arbitrary free port and assigns it to our client. Since we are supposed to receive the Hello World message from the server, we get the input stream bound to our socket. For convenience, we wrap it with a data input stream. Finally, we use our wrapped input stream to read the bytes sent by the server side, decode them as a string, and print it. Remember, the connection will be closed by the runtime on our behalf. You may pause this video and assess your ability to apply what you have just learned. You can share your thoughts and questions in the comments below. Time for Python. Python Socket API is defined under the Socket module. As opposed to the Java Socket API, which has a dedicated server socket class for the server-side system calls, such as binding and listening, the Python Socket API encapsulates all related system calls under one class called Socket. In addition to this class, convenience functions are defined, starting with the createServer function. As its name implies, it allows the creation and binding of a server to an endpoint. You may wonder why we need to specify our IP address. Well, the host that will run our server may have several IP addresses, so we may want to restrict our server to listening to only connection requests received through a specific IP address. If we want to accept connections received through any of our host IP addresses, then we just keep it empty. The create connection call returns the equivalent of a server socket. Just like in Java, the server socket object supports an accept method, which listens to incoming connections. It returns a tuple representing the accepted connection and the client endpoint. Notice that in Java, the accept method returns a socket object that encapsulates the client endpoint. On the client side, we can use another convenient function called createConnection. It takes as a parameter the server endpoint in terms of IP address and port and returns a representation of the connection. This is the socket object. We use the socket object on each side to send and receive bytes. Whatever we write on one side through the send method gets read by the other through the receive method. Notice that in Java, the socket class does not have send and receive methods per se. It rather delegates such operations to its input stream and output stream instance variables. This is because in Java, all I/O operations are supported by the java.io package streams. Finally, and just like in Java, the Python socket class supports the close method that allows closing the connection on both ends. Let's go back to our Hello World example. Here is a reminder of how it goes. The client opens a connection with the server. The server sends Hello World to the client. The client prints it out on its screen. Finally, the client and the server close the connection. We start by developing the server code. First, we decide on the port we want to bind our server to, and we create the corresponding endpoint tuple. Notice that we left the IP address empty to tell our operating system to accept incoming connections through any of our IP addresses. Then we import and use the create server function to create and bind our server. Although not shown explicitly like in Java, this call may raise an exception if the chosen endpoint is already granted to another process. Also, notice the use of the with construct to let Python runtime close the server socket and release the endpoint on our behalf before ending the program. Then, we create an endless loop to allow our server to continually accept a connection from the next client and interact with it. Inside the loop, we call the accept method on our server socket object. This is a blocking call, waiting for an incoming connection request. Once received, it will be returned as a socket object. Finally, we use the socket object to send the hello world message after encoding it as bytes. Here too, notice the use of with construct. It allows the Python runtime to close the connection properly on our behalf, avoiding memory leaks. Let's now move on to the client. We start by specifying the server endpoint in terms of IP address and port. In this example, we assume that the server will run on the same machine as the client, so we use localhost as a special value for the IP address. Then we import and call the create connection function while specifying the server endpoint. By doing so, we issue a system call to the OS, asking it to open a connection to the specified server. Here too, we use the with construct to let the runtime environment close this connection on our behalf before the program ends and avoid memory leaks. This connection opening may raise an exception if the specified server is unreachable. Remember that the operating system will pick an arbitrary free port and assign it to our client. Since we are supposed to receive the hello world message from the server, we call the receive method on our socket. Finally, we decode the received bytes as a string before printing it out. Remember, the connection will be closed by the runtime on our behalf. You may pause this video and assess your ability to apply what you have just learned. You can share your thoughts and questions in the comments below. In the next videos in this series on the client-server model, we'll learn that client-server interaction is more than just I/O. This is why we need protocols, and we'll talk about them and their vital role in detail. Finally, we'll cover a real-life case study whereby we'll design and implement an interesting client-server application called FX. I hope you're enjoying our step-by-step journey towards demystifying the client-server model and programming. To level up as a computer scientist, show love and appreciation and hit the subscribe button.